Picture the following experiment where within this experiment you're holding a ball with your hand above a certain height, at a certain height from the ground. And then you let go of this ball. Now we know from experience that this ball starts accelerating, starts moving towards the ground. Now the question is, where did the motion come from? So in order to answer that question, we need to understand the concept of energy. Now, energy in physical terms is the ability to do work in an abstract physical definition. However, what this actually means is that we say that an object has energy if it's able to change something in the following sense. So, if the object can move or deform, form, or heat up, or cause something else to move, cause motion, we say that this object has energy. Now, in order to understand energy more fundamentally, we examine the following different forms that energy can take. So in the first example, a moving car has what we call a kinetic energy, which is related to the motion of this car. And the reason why we say that a moving car has energy is because suppose that this car, for some reason, collides with another car that is stationary, that is not moving. Then this car will transfer some of its kinetic energy to the other car, causing it to move. Hence we can say that this car was able to do work on another object, hence it has energy. Another example, another type of energy, which we've discussed earlier, the one with the ball example, where if we have a ball at a certain height away from the ground and we let go of that ball, the ball starts to accelerate downwards towards the ground. This form of energy is what we call the gravitational potential energy. A third example includes a bow and arrow, where when the string of the bow is taut and the arrow is loaded, as in this configuration, the bow has what we call an elastic potential energy. And once the archer lets go of the string, this elastic potential energy is transformed into kinetic energy of the arrow. Hence, energy is some sort of currency that allows us to understand why certain things move the way they do. And as we can note from examples 2 and 3, even though some things or some objects may appear to be stationary at first, that does not mean that they do not have energy. On the contrary, some stationary objects, such as the bow and arrow in the hands of the archer, appear to have no motion at all, but once the archer lets go of the string of the bow, the elastic potential energy is converted into kinetic energy and it manifests as motion of the arrow. Now, the SI unit of energy, or the way we count energy, is in a unit called joules, abbreviated by J. But there also exists other units to measure energy. Some of them include the kilowatt hours, which we use to measure electrical energy. While the calorie is used to measure heat energy, and the electron volt involves measuring the energies of atoms or the spectrum of atoms. Now, in order to study energy more rigorously, we classify energy into two types. One that is related to big day-to-day objects that we deal with on a daily basis, which is the mechanical energy. This is directly related to quantities we can observe directly with our eyes and measure in the normal natural world, which include the the motion of our day-to-day objects or large-scale objects, the positions relative to a given frame, and the deformations, possibly, in case of elastic potential energies. This type of energy measures the large scale objects, such as cars moving with a constant, with a given velocity, will have some sort of mechanical energy in the form of kinetic energy. A ball falling down or held at a given height has what we call a gravitational potential energy due to the presence of Earth, which is attracting the ball. On the other hand, internal energy deals with smaller objects that compromise matter itself. For example, the atoms, the molecules that form the objects that we have, they too have their own motion, they have their own vibrations, their own rotations, their own potential energies. So the internal energy measures the particle motions or quantifies these energies resulting from particle motions. It quantifies the heat content within a certain material. And then it also quantifies the interactions between the molecules. An example of internal energy includes when you rub your hands together, for example, the friction, you're dissipating energy, the kinetic energy that you're forming with your hands is being dissipated due to the friction between your hands. And this friction turns into heat energy, which is absorbed by the atoms and molecules that form the skin of your hand. So that's an example of internal energy. And now we come to the most fundamental principle about energy, which is the principle of conservation of energy, which states the following. Energy is neither created nor destroyed. It only changes from one form to another. So in other words, what this is saying is energy does not come out of thin air. So you cannot create energy, and energy does not dissipate into non-existence. It's always there, it just changes from one form to another. So if we go back to the ball example, when the ball is at the first position, so at a given height from the ground, we say that due to its position relative to the ground, it has potential energy. Once we let go of the ball and the ball starts falling towards the ground, this energy is then transformed from potential energy to kinetic energy in the form of motion. The particle starts to move, it gains velocity. So hence, the potential energy didn't just disappear, it transformed into another form, which is kinetic energy. Upon the definition of the quantity of energy in physics, one would ask the following logical question. Why should we define energy, and why should we care about the different forms of energy? Well, it turns out energy is quite a helpful quantity to understand and calculate within a physical system, because it will allow us to predict the motion of certain objects. If we know the energy of an object, we can predict its motion. If it can also help us analyze physical systems, complex physical systems, in order to understand how they evolve in time. And finally, it's going to help us understand and study real-world phenomenon in a simple yet powerful way. So now, one of the most fundamental forms of energy is the the one related to the motion of an object, which we know as the kinetic energy of the object. We'll study this form of energy in detail in the next video and understand how its formula came to be and how to apply it, so we have our first real tool that allows us to compute the energy of physical systems.